Today's topic is non-homogeneous differential equation. So first of all, in order to get the solution for this equation, so we have to write as 2x minus 4y plus 3 into dy by dx is equal to minus of x minus 2y plus 1. So again dy by dx will be minus of x minus 2y plus 1 by this is 2x minus 4y plus 3. So if you observe this, there are the numerals at the last. So we have to identify that it's a non-homogeneous differential equation. If it's a non-homogeneous differential equation, they are of two models. The first model here is, so if you observe here, dy by dx is equal to, this is minus x plus 2y minus 1 by, this is 2x minus 4y plus 3. So we have to take the quotient of x. The first of all, the quotient of x is minus 1. And later the quotient of y is, this is 2. And here the quotient of x is 2 and the quotient of y is minus 4. So this will be a1, b1, a2, b2. So this is a1, so this is b1, this is a2 and this is b2. So if you consider a1, b2 minus a2 b1, so what happens here? So 1 into 4 is 4 minus, and this is 2 into 2, this is again 4, so which is equal to 0. If this determinant is 0, a1 b2 minus a2 b1 is 0 here, then there is a process for solving. So the process here will be dy by dx is equal to, so dy by dx is equal to, this is minus times of x minus 2y, this is minus 1. And this here, if I take 2 as common from this, so this will be x minus 2y again plus 3. Now we have to take, so here if you observe, this is x minus 2y and this is x minus 2y. So now I am going to take x minus 2y as common factor. That is x minus 2y is equal to z. So this substitution we have to use. So if the determinant is 0, if it's not equal to 0, in my previous videos I said that we have to take small x is equal to capital X plus h and small y is equal to capital Y plus k. And if the determinant is 0 here, we have to choose this model. So this, for x if I make a derivative, this is 1 and this 2, and for y it is dy by dx is equal to, again this is dz by dx. Now I am going to take the value of dy by dx. So for that 1 minus dz by dx is equal to 2 times of, this is dy by dx. And what about the dy by dx? So dy by dx value will be 1 by 2 times of 1 minus dz by dx. Now in place of x minus 2y, I'll put z, and in place of dy by dx, I'll put this one. So this is equation 1 and this is 2 and this value is 3. Substituting 2 and 3 in equation 1, so we'll get, in place of dn 2 and 3 in 1 in equation 1. So in this equation, in dy by dx, if I keep this one, that is 1 becomes, that is half times of 1 minus dz by dx is equal to minus x minus 2y. I have to replace by z. This is already minus 1 and this is 2z. This will be 2z plus 3. Now I am going to send this half to other side. That is 1 minus, this is dz by dx is equal to minus 2 times of, this is z plus 1 by, this is 2z plus 3. Now see here, this is 1 minus dz by dx value will be, this is minus, if I multiply this will be 2z plus 2 by, this is 2z plus 3. And now if you see, I want dz by dx. So now dz by dx value will be, see here, if I send this dz by dx to other side, this will be plus dz by dx and this will be, so if I send inside, so this will be 1 plus 2z plus 2 by, this is 2z plus 3. And now see here, dz by dx value will be, if I take 2z plus 3 as LCM, this will be 2z plus 3 and this is again 2z plus 2. And now this value will become dz by dx is equal to 2z plus 2z is nothing but 4z plus 5 by this is 2z plus 3. Now variables and separables method. I am sending z to one side and x to one side. So if I send this one, this will be 2z plus 3 by this is 4z plus 5 into dz is equal to dx. After separating variables and separables, here variables and separables method, after choosing, now we have to integrate on both sides. So here is a small logic for us. So we have to choose numerator is equal to a into denominator plus b. So in this formula, if I apply, so what is the numerator? This is 2z plus 3 is equal to a times of what is the denominator here? This is 4z plus 5 plus b. So we have to find out the values of a and b for that. So if we choose the z quotients, z quotient is x is equal, the z quotient is 2 here and the z quotient is 4a here. 4a and a value will be this is 2 by 4 and a value is equal to half. So I got the value of a, and after that this is quotient of z. And now if I equate the constants on both sides, see what happens. Here the constant is 3 and here the constant is 5a and plus b. See here, what is the a value? A value is half. So this will be half plus b. So this is 3 minus this is 5 by 2 is equal to b. This is 6 minus 5 by 2. 6 minus 5 by 2 is equal to b, and the b value here is again half. So I got the value of a and b, and after getting a and b, our 2z plus 3 value will become, see here, 2z plus 3 value is equal to a. In place of a, I am writing half times of this is 4z plus 5 and b is again half. So now we have to use this integration. See, this is nothing but this is 2z plus 3 by 4z plus 5 dz is equal to integral dx. So in place of 2z plus 3, I am going to write this one. So in place of 2z plus 3, I am going to write half times of this is 4z plus 5 plus half by, here it is already 4z plus 5 into dz is equal to integral dx. So if I separate this one, half times of this is 4z plus 5 by 4z plus 5 dz plus again half times of this is dz by half times of dz by this is 4z plus 5 is equal to integral dx. So this value, if you see here, if you observe properly, so I can easily cancel this one for one time. So this is one time, so this will be half times of, so this is half times of 1 dz plus this is half times of this is dz by this is 4z plus 5 is equal to integral dx. So 1 dz is nothing but the integration of 1 dz is nothing but z, and this is half times of, so here the derivative here for z is dz and there is no 4 here, so this will be 1 by 4 times of log of this is 4z plus 5 is equal to integral dx is nothing but x plus c. So if I send this 2 to other side, see what happens, z plus 1 by 4 times of this is log 4z plus 5 is equal to this is 2x plus 2c, it is again a constant. So what is z here? So z is nothing but, I'll show you the z value. The z value is nothing but x minus 2y. So x minus 2y is equal to z. So as we have z is equal to, x minus 2y, if I substitute here, this will be x minus 2y plus 1 by 4 times of this is log 4 times of x minus 2y plus 5 is equal to this is 2x plus c. So this is x minus 2y plus 1 by 4 times of this is log, if I multiply this will be 4x minus 8y plus 5 is equal to 2x plus c, and this is the general solution and this is the final solution. And let me explain you once again. So if you see the numerals here, If you see the numerals here, you have to identify that it's mostly non-homogeneous differential equation. For that, we have to transform the equation in the form of dy by dx is equal to, and next later after multiplying with minus, so we have to check which model it is. So in order to check this, so this is the quotient of x is -1 and the quotient of y is 2 here, and the quotient of x is 2 and the quotient of y is -4. So you have to find the determinant. So this is 4 1s are 4, minus 2 2s are 4, and this is 0. If the determinant is 0, we have to take common from the question itself. See, from if you observe from the question, so this is the common part, that is x minus 2y in the numerator as well as in the denominator. So if I choose x minus 2y is equal to z, then we have to find out dy by dx. In order to substitute here, I have differentiated derivative on both sides. If I derive on both sides, for x it is 1 and for y it is dy by dx, and for z it is dz by dx. And after getting the value of dy by dx, I have to substitute the value of dy by dx as well as z in the given equation 1. So in the given equation 1, after substituting each and every value, so I have to transform this equation as dz by dx is equal to, so I have to send z to one side and x to another side. So after variables and separables method applying, and we have to use this one, the numerator is equal to a into denominator plus b. So the numerator is nothing but 2z plus 3 is equal to a into the denominator 4z plus 5 is equal to b, and after equating the quotient of z on either sides, then this will be 2 is equal to, this is 4z, 4a, and a value is equal to half. If I equate constants on both sides, then 3 is equal to, this is 5a plus b, and if I substitute the a value here as half, then I got the b value as half. So if I keep the values of a and b here, then 2z plus 3 value is like this. So we have to find out this integration. So in place of 2z plus 3, I am going to write this value, and if I write this value, so if I separate it, then this goes by one time and this remains like that. So here 1 dz is nothing but z, and for here for z the derivative is 4 dz, and there is no 4 here, so I have to divide with 4, and this remains as log of 4z plus 5. So as you know that the z value is x minus 2y, so we have to replace z with x minus 2y, and after replacing this will be the final answer. This is how we have to solve. This is so simple to identify. If you see any numerals after dy by dx, then you have to identify that it's a non-homogeneous differential equation, and we have to find out the determinant. If it's equal to 0, then we have to take common from the question itself. If it's not equal to 0, we have to take a substitution that small x is equal to capital X plus h and small y is equal to capital Y plus k. And I've uploaded many videos regarding this. Please watch those, and if you really like, you know what to do, please subscribe to this channel, share it with your friends, and raise your thumb if you really like.